Hello guys, welcome back to John's Workshop, and in this video we're going to be trying to finish off the remaining make pieces that I need to do for the Marc engine. So as you can see on the board behind me, this is kind of the final bits and pieces make, and there's a few pieces that are still outstanding. They're all quite smallish bits, and what I'm trying to do here, rather than this drag on and on and on, rather than going into 4 separate individual episodes, what I shall do here is show bits of each of these as we go through this video, and if it's something that's noteworthy, i.e. something special about the setup that I've tried to do, and certainly on the valve support brackets I've got a plan in mind how to make those with the minimal amount of wastage, and I'll show that because it's quite an interesting concept that I've thought around how to get those out of a very small bit of brass. So bits like that, I'll show the special bits, the bits where it's important, and the bits where it's just standard machining I'll cut those out, but I'll talk you through how we got there at the end of the episode. So without any further babbling, we'll move to the command and control center. We'll just have a quick flick over those 4 areas to show you the bits that I'm talking about, and then we'll move into the video. And I'm not quite sure what order I'm going to attack these in yet, but you'll largely see the manufacture of those 4 main bits as we go through the rest of the video. Okay guys, we're in at the screen, so we'll just take a quick look at those 4 areas. So the Conrod, you can see here, so the plans call for this to be steel. I don't know what I'm going to make that out of yet. We'll have a rummage through what I've got. The valve lever support brackets, which you can see better on this picture here. So we've got this shaft that runs through the middle into each of the valve lever arms that I've already made, and then there's these 2 brass support brackets that hold that shaft in place. So there's those 2 brass brackets to make there. There's the cam follower assembly, which also attaches to the right hand lever arm, and you can just see it there riding on top of the cam. So there's a little tiny stub shaft to make, and the actual cam follower itself, again, that calls for steel, so that's going to be steel on steel. I might be changing that out, don't know yet, I'll figure that out as we get to it. And then finally the fuel tank support bracket, which you can see here, again, that's brass, so a bit of machining to do, fairly basic, and a slot. It calls for a hole. I'm actually going to put a slot in so that I've got some in and out movement as well, which I think is quite important to try and get the flame, as well as angular adjustment left and right this way over the hole. Also I've got some in and out adjustment as well, so I'm going to slot that, I think. So those are the 4 bits. So I will bring you back in a moment. I think I'm going to attack these 2 brass support brackets first, so you'll probably see me on the mill just shortly as we're setting up. I'll get all the blocking out done up front, and then as we get into the bit that I think's of interest and note and maybe helpful for others in terms of how we're going to get these 2 out of a small bit of brass, I'll show you that on the mill when we get to that point. So we're on with the valve shaft support brackets, and I've blocked out a small piece of brass, and what I'm going to do, so I've marked them up so you can see I've got 2 just roughly general that shape to come out of them. Now if I was making these individually, that would present a little bit of a work holding problem, not too difficult, but by making them together like this, so I'm finished size this way on the width, I'm finished size this way on the thickness, I'm oversize on the length, and that's just the bar stock. So basically what I'm going to do is mill out this rectangular piece on both sides, and I can just hold it in the vise for doing that. And then once we've got that done, I'm going to have a datum at this end of the part and a datum at that end of the part on the DRO, centre dot the 2 holes, and then I'm going to use a pair of dividers to actually mark the radius on both using the centre dot. And then I'm just going to file these for what they are. Rather than messing around with the rotary table, I'm just going to file this radius on the end, and then we'll chop it in half after we've drilled and reamed the 2 holes, once I've marked it out, and then we'll just file these to finish them. And then we've got some holes to put in through the flange piece at the bottom for actually fixing them to the engine. So that's roughly how we're going to do that. I'll just show you a tiny bit of the milling out of this rectangle piece just now, and then I'll bring you back a bit later on in the manufacture. And then guys, slight digression, we've gone into making some brass letters obviously, so I've made the I and the T, so I'm just about to go ahead and make the S and the H. I'm joking. So this is our, what you saw me making earlier, our two valve support brackets, and this is the fuel tank support bracket. So what I'm doing, so I've blocked that out, I've not filmed all of it, you can see what I've done, blocked it out to overall sizes, taken these two corners out, and the next job I've got to do now is mill a couple of bevels on each corner. So I'll just show the setup of that and a little bit of the machining, and I'm trying to get all the milling out of the way of brass at least while I've got the milling chuck in the spindle, and then we'll switch out for the drill chuck as we start putting all the holes in these and finishing them off. So I'll bring you back in a minute when we're setting the T up for some bevel milling. Just thought I'd show this setup. So it's 45 degrees the angle I need to put the bevel on, so dead straightforward. Oh, you'd have thought so. So I've got a 45 degree ground square, but unfortunately that is just slightly thicker in section than the brass bit, therefore the vice is clamping up on this first. Now I could faff around and 3 pairs of hands using blocks and parallels and whatever, and so I trap the brass before I bite on this, but I thought this was an ideal opportunity to use my Christmas present from Mrs. John's workshop for the first time. So basically I've got a inclinometer, digital inclinometer, and what I've done there is I've just set that to the top of the vise so I know it's reading 0, and I've got it sat on a parallel because it's obviously magnetic, and I'm, you know, on repeat measurements I'm anywhere between 44.95, 45.05, so perfectly happy that's as close to 45 degrees as I need to be. And all I've been using is my little knocker and just gently tapping it either way, you know, a few seconds, and that's 45 degrees, dead simple. So that's another handy tool for the workshop for simple setups like this, and using it on a parallel when you've not got a magnetic workpiece just helps setting up. So I'll bring you back in a minute when we're ploughing some of this brass off. So the last operation we did on the fuel tank support off camera was to put the slot in for the threaded part of the fuel tank to go through. So that's plain 6mm slot on centre, nothing special about that. So now we've got our letter I back in the vise again, which is the valve supports, and we've got our stop set on one end of it, and I'm going to mark this end of it with a Sharpie so I know which end I've got up against my stop, and that's going to be important just shortly. I'm now going to use the edge finder, and I'm going to touch off this face, this end face in x-axis, and also this end face in the x-axis, and I'm going to set 2 separate datums up because we've got 2 parts within this letter I. So I will bring you along on that journey, and then we'll crack on with the next part, which is marking out the radiuses and then finally putting the 2 holes through for the shaft to go through. So I'll bring you back in a minute when we're setting up our x-axis. So we're in absolute. I've zeroed on the edge that you've just seen me find. I'm now going to move in 3mm because that's my that's the radius of my edge finder. So there we go, 3mm. So I now know that my absolute X0 is on that left hand end. So we're now going to come back and edge find the right hand end. So that's my reading, 34,705. If I took 3mm off that, it's 31.7, which is imperial, which is what I would be expecting. So it's an imperial bar stock size on the length, so that's fine. So what we're going to do now is just move to incremental, and I'm going to 0 my X, and then I'm going to wind in my 3mm again. I'm going to 0 again. So I now know my incremental X0 is the right hand side of the part, and my absolute X0 is the left hand end of the part. So 2 datums. It's not really the right way to do it. There is another way of doing it on here that I've not read the instructions on yet, where you can set multiple datums up on it within the memory of the DRO. I've not read it. I've only got 2 datums to deal with. Just as easy to do it with absolute and incremental for what I'm doing here. That's perfectly fine. So just a way of having 2 separate datums on one part, nice and easy using the DRO if you've got one. So we'll now move on to, I'm just going to centre pop very lightly the 2 holes with a spot drill, and then we'll mark out the part for the radiuses that we need to be hand working on these once I've split them apart. As if by magic we're back. So we're now going to use some incredibly high-tech technology, and we've got a pair of dividers, and we've set those to the radius that we want, and we're just simply going to drop that into that little centre dot we've put in and mark into the blue our radius. So hopefully you can see the idea now. So there's our 2 parts marked out for the handwork operation, and with enough space between them for me to slide a hacksaw through there and split them into 2. So we're just in the vise now, finishing these radiuses off. So we've obviously chopped the 2 parts in half. I'm just working to my scribe lines, both sides of the part, and it's not taking too long really. So there we go, that's got us almost to our scribe lines. I've left a tiny bit on, and we're just going to basically draw file that to the final profile, just to tidy the filed edge up, and then we'll repeat the same exercise on the other one, and that'll be these 2 parts complete for the shaping work at least. And then I've just got 2 holes to put through the bottom flange, which I'll probably do off camera because there's nothing special about that. So guys, onto the Conrod. So I've got myself a piece of 01 or ground flat stock or silver steel or whatever you want to call it, gauge plate, many names for the same thing. It's 6mm thick, needs to come down to 5mm, and I need to block it out this way as well for my biggest end. There's a big end and a small end, and they are different. So I'll do that off camera because that's just plain straightforward milling, and I'll bring you back when we're getting into the meaty bit of the Conrod manufacture. Right guys, we've got our piece of stock blocked out to our two dimensions, so thickness and width. The length is just as it came as the stock, so that's over length at the minute. So what we're going to do now is we're just going to load that back in the vise. Anywhere will do, because we've only got one set up. I've got that set on a couple of parallels. And I've tapped that down fairly gently because I want to get these parallels out, he says. So we're going to pick up on this now, set our datums, and then we've got a couple of holes, different sizes, to drill and ream in here. My X, I'm not too worried about picking up exactly. All I'm going to do is hover over one end with the spot drill and then find my centre point of the stock, and then I'll pitch out each way to where the holes are, and that will leave me some stock on each end then when we come to put the big and the little end on. So we'll do that next, and I'll bring you back when we're doing a bit of that. So I've got my small rotary table now just put onto the mill table, and we've clocked our central bore up and zeroed our X and Y axis over the centre of the rotation of the rotary table, so I know I'm bang over the centre. So the next job now is to set a little fixture plate up on here that's going to hold the Conrod, and what we've done with the Conrod is we've marked that out so I can see where my sort of central wasted portion of the Conrod will be. So I've got the lines on there, and we're basically just going to use the rotary table for creating the two end radiuses, and I'm just going to work into these lines, and then we'll move to the vise to take the waste section out and just blend all of that into the radiuses at each end. So hopefully nice and simple. So I'll bring you back in a moment when we've got everything set up and we're ready to put the rads on the end. Right guys, excuse the noise, I've got my heater on, that's what the noise is. So I've got my fixture plate, little fixture plate, up on the rotary table. We've got that clamped down with a couple of clamps. We've put our Conrod up. I've got a piece of drill rod, or high speed steel, silver steel, ground to 4mm diameter in the 4mm reamed hole. And basically what we've done is we've dropped that in to line the part up, and used another clamp to clamp the part. Now ideally I'd like two clamps on this, but there's no other holes in the fixture plate. I could drill one in, but I'm going to give this a go with just the one clamp on. I'm going to be taking it ultra steady, and we've not got lots of material to get off anyway, and I'm going to be using a fairly small end mill, and it's pretty, you know, it's pretty solid, it's not going anywhere. So that's the job. Dead simple setup, just using, I know I'm over 0-0 with the table rotation, so just using the ground rod. There will be some inaccuracies in that, I'm holding it in a drill chuck, but for what we're doing, just to profile this radius, I think that'll be perfectly good enough. And when we've done that, we'll just switch it around, swap the setup round, and put the 3mm hole over the centre line, put a 3mm bit of drill rod in, line it up in exactly the same way, clamp it up, and put the radius on the end in much the same way. So I'll bring you back, show you a little tiny bit of that when we're doing the machining. There we go, that's got our Conrod ends done. The big end and the small end, and they're slightly different diameters, both of them. So a bit of tidying up to do, but reasonable surface finish, just needs a tiny bit of a polish for cosmetics. So the next job now is we'll get this into the vise and we'll get the middle section wasted away. Right, I've gone for something even easier, guys, because the Conrod centre section's parallel and the lines that I've scribed were scribed with relation to the edge surfaces. I don't even need to faff around with pins or anything on this. Nice and simple, straight in on a parallel, and I'm just going to come down until I break my scribe line. I'm going to use an end mill with a corner radius on it so that I blend in with the corner rads that I've got from the end mill where I've milled these ends. The drawing actually shows that as a sharp corner. I don't like the look of that, so I'm going to put a radius in there if I can get away with it and don't need the clearance. I certainly don't need it on the big end. I just need to check the little end to make sure I've got clearance inside the piston, and I don't need to square that off, and if I do, I'll just do that by hand afterwards with a file. So I'm going to try and blend these in on the mill. So straightforward milling. I'll bring you back when I've got that complete. So guys, these are the final bits and pieces. There's a few more on here than I said would be at the start of the episode. So we've got the Conrod finished. I've just got a tiny bit more tidying up to do with that, just cosmetic wise, but functionally and dimensionally complete. We've got the fuel tank support bracket that you see me make bits of in this video, so that's complete, other than again a bit of cosmetic work, a bit of polishing. We've got the two support brackets for the valve assembly complete, and again tiny bit of handwork, polishing required to finish those off. And then the bits that weren't in the start of the episode that I've also made. So I've made a couple of knurled very thin nuts, and these are for the fuel tank to hold it onto the support and give me the option to lock it at different heights and move it backwards and forwards in the slot. And I've made the cam follower, which was a bit that I'd still to make, and I've not filmed any of these bits, guys, because you know it's basic stuff. OD, a tapped hole through the middle and a knurl on the outside. So just, you know, in terms of keeping these videos at a reasonable length, there's bits here that I've not filmed. Same with the cam follower, really nothing special about that, other than I've strayed away from the plans again. So the plans call out for this to be just steel, is what it says on the plans. I've gone for brass, and rather than a sort of a face contact, a full face contact at the full width of the cam follower, I've put a groove in it, and we've got an O-ring on there, so the OD of the O-ring is about the same size as what the plan calls for, and we're just going to try that. Idea being that the O-ring, well, it would help if you could see what I was doing. So I've got the cam there, the O-ring will be the surface in contact with the OD of the cam. Two reasons for that I can think of, or three reasons, main reasons for this. One is to reduce the surface contact area, reduces more drag on the engine. That's the first one. Secondly, it's a rubber O-ring, I can replace it dirt cheap. It's not going to wear the surface of the cam out during running, whereas steel on steel would eventually mar up the surface of the cam probably, and as I said, less surface area in contact. And the third one, because this is brass, it creates a nice bearing surface for the shaft that sits within it, which is also called out as steel on the plan. So steel on steel is what effectively the plans call for. Like materials don't tend to go together very well, especially when you need a running, you know, when they're running together. So we've got steel on brass for the cam follower, and then rubber onto steel. So we've got rid of the like materials. So that's, you know, and again, that's just me playing around. The only other thing I've done is I've put an extra hole in this brass piece that I turned earlier, which was missing, so that's done. So largely that is all of the machining now complete. So that's everything to actually start assembling the engine in anger. So exciting times, just a bit of handwork to do. So with all that being said, I will bring you back to the board and we will close this episode out. Well, there we go guys, as I said, exciting times. So really pleased to have got to the end of all the little bits and pieces. I think a lesson learnt for next time, the very first bits I attack on an engine will be all of those little bits and pieces rather than leaving them till the end, because it's just kind of, when you've done the exciting bits, they're all the kind of sort of nitty little gritty bits that you kind of been putting off. So it's nice to have got all of those out of the way, and I can now absolutely focus on starting the first assembly. And I've assembled nothing on this engine, you know, I've just made all of the bits. I've done no trial runs, no dummy runs, so hoping that the plans are good and everything's going to fit together. So I'll probably have a break from this for a couple of weeks while I'm going through the final bits of work to polish everything up and assemble it and get it where it needs to be. I've got a friend, in the absence of my engraving machine being commissioned yet, it still needs stripping, and that's probably what we're going to be getting into over the next couple of weeks. Strip that down and start making that good. So I've had a friend who's got laser engraving capability, or certainly laser burning capability, and he's made me some a badge plate up for the engine, so that's going to look quite nice. And I've probably got one more bit of machining to do to make a backing plate for that, which I'll not film because it's fairly straightforward. So next time we think and look at the Marc engine, it should hopefully be in one piece, and it will be testing time to see whether it actually works or not. So all very exciting. So thank you all very much for watching. Thank you to the subscribers, thank you to the new subscribers that have come along, and we will catch you all very soon on another video when we'll be making something else.